From moon landings to mobile phones, many of the far-fetched visions of science fiction have transformed into reality. In the latest example of this trend, scientists report that they have developed a powerful printer that could streamline the creation of self-assembling structures that can change shape after being exposed to heat and other stimuli. They say this unique technology could accelerate the use of 4D printing in aerospace, medicine and other industries. The researchers are presenting their work today at the 255th National Meeting and Exposition of the American Chemical Society, FRAX, the world's largest scientific society, is holding the meeting here through Thursday. It features more than 13,000 presentations on a wide range of science topics. We are on the cusp of creating a new generation of devices that could vastly expand the practical applications for 3D and 4D printing, H. Jericho, PhD, says. Our prototype printer integrates many features that appear to simplify and expedite the processes used in traditional 3D printing. As a result, we can use a variety of materials to create hard and soft components at the same time, incorporate conductive wiring directly into shape-changing structures, and ultimately set the stage for the development of a host of 4D products that could reshape our world. 4D printing is an emerging technology that allows 3D printed components to change their shape over time after exposure to heat, light, humidity and other environmental triggers. However, 4D printing remains challenging, in part because it often requires complex and time-consuming post-processing steps to mechanically program each component. In addition, many commercial printers can only print 4D structures composed of a single material. Last year, Key and his colleagues at Georgia Institute of Technology, in collaboration with scientists at the Singapore University of Technology and Design, used a composite made from an acrylic and an epoxy along with a commercial printer and a heat source to create 4D objects, such as a flower that can close its petals or a star that morphs into a dome. These objects transformed shape up to 90% faster than previously possible because the scientists incorporated the tedious mechanical programming steps directly into the 3D printing process. Building on this work, the researchers sought to develop an all-in-one printer to address other 4D printing challenges and move the technology closer to practical application. The machine they ultimately devised combines 4 different printing techniques, including aerosol, inkjet, direct ink write and fused deposition modeling. It can handle a multitude of stiff and elastic materials including hydrogels, silver nanoparticle-based conductive inks, liquid crystal elastomers and shaped memory polymers, or SMPs. SMPs, which are the most common substances used in 4D printing, can be programmed to remember a shape and then transform into it when heated. With this new technology, the researchers can print higher quality SMPs capable of making more intricate shape changes than in the past, opening the door for a multitude of functional 4D applications and designs. The researchers can also use the printer to project a range of white, gray or black shades of light to form and cure a component into a solid. This grayscale lighting triggers a cross-linking reaction that can alter the component's behavior, depending on the grayscale of shade shined on it. So, for example, a brighter light shade creates a part that is harder, while a darker shade produces a softer part. As a result, these components can bend or stretch differently than other parts of the 4D structure around them. The printer can even create electrical wiring that can be printed directly onto an antenna, sensor or other electrical device. The process relies on a direct ink write method to produce a line of silver nanoparticle ink. A photonic cure unit dries and coalesces the nanoparticles to form conductive wire. Then, the printer's inkjet component creates the plastic coating that encases the wire. Currently, Key's team is also working with Children's Healthcare of Atlanta to determine whether this new technology could print prosthetic hands for children born with malformed arms. Only a small group of children have this condition, so there isn't a lot of commercial interest in it and most insurance does not cover the expense, Key says. But these children have a lot of challenges in their daily lives, and we hope our new 4D printer will help them overcome some of these difficulties.